This session we're going to start using the T-Splines plugin for the first time. Please make sure you've installed it before starting with this session. I'm going to explain a little bit first about why we're going to use this plugin, what are its benefits compared to Rhino. Like mentioned in the introduction, T-Splines is a sub-D modeler plugin. Sub-Ds is a geometry type that lies in between NURB surfaces and meshes. Because of this, it shares both its benefits. Unlike NURB surfaces, T-splines are not constrained to a rectangular organization. They can have any topology. And unlike meshes, T-splines can be rendered in any resolution. They are resolutionless, if you may. The geometry is described using a mathematical function using control points and weights, like a NURB surface. I've set up some temporal geometry for you to play with to understand the difference a little better. On the left we have a rectangular coarse mesh, built up from faces and vertices. Let's turn on its control points and let's move some around. As you can see, the edges are always lines, so the mesh appears pixelated. Now the next object is the same mesh, but after some Catmull-Clark subdivision steps. You'll see that the mesh looks more refined and more smooth. If you zoom in, you'll still notice the jagged edges. Next up is the T-spline geometry. As you zoom into this geometry, you'll notice that it is not jagged, it is without resolution, like a NURB surface, but with the properties of a mesh as well. Finally, we have a poly surface that was converted from the previous T-spline object. This object is also smooth, without resolution. The only difference is that it consists of different patches, as NURB surfaces have an inherently rectangular organization. The skin we're going to model is topologically complex, so we'd have to use multiple surface patches in Rhino to represent its shape. The problem then becomes surface continuity, as the skin will look fragmented very soon using this method. The second option, the option we're going to use, would be to model a coarse mesh to represent the facade. When we've done that, we'll use some subdivision techniques to get the final smooth shape right. We're going to use T-splines to assist us in modeling the mesh, as it has some great mesh manipulation tools that Rhino is lacking, and more. Let's go over the main toolbar and the commands we're mostly going to use. All the way on the left, we find the Enable and Disable Edit mode. This button enables or disables the T-spline edit mode, enabling some cool commands and tools we will use later on. Up next, we have the Convert button. Here you can convert a T-spline object to a watertight poly surface or mesh object, or the other way around. Next are some T-splines primitives and some other methods to create a T-spline object, like from a set of curves. Now the next one is a smooth toggle. This command lets you switch between a smooth representation of your T-spline and a rough or coarse representation of your T-spline. Usually modeling is done in coarse mode, as it doesn't take that much processing power. Once in a while you switch to smooth mode to see how your T-spline will look like. The next commands are commands that will edit and manipulate your geometry, like extrude a face, add or delete faces and edges, weld points and edges, etc. The last set of commands lets you adjust settings when you want to convert your T-spline to a poly surface. The cool thing is that here you can set the regions for your surface patches, as almost always when you model a T-spline geometry and you convert it to a NURB surface, you end up with a poly surface or a set of surface patches patched together. Alright, enough talking already, and let's start modeling. There are some other small things to take into account, but we'll go over those when we'll model our coarse mesh. In the next session we'll start modeling our skin.